Hello everyone, I am Deepak Paliwal. So in the previous lecture we have learned about the strain field and what are the components of that strain fields are present in case of screw dislocation. So we have evaluated or we have calculated the various strain components, and what we have observed that we have epsilon xz and epsilon yz. That means the screw dislocation has only the shear strain field. Okay, in this lecture we will learn about the stress field around stress field around screw dislocation. Okay, so here Lame's equation is very much important to understand the stress field. What is the Lame's equation? Like sigma ij. Here sigma ij means z plane, ith direction can be written as 2g epsilon or eij plus lambda kk, that is the Lamb's constant. Delta ij, this is the function. Delta ij means this is the function when I equal to j. This delta ij becomes 1 when delta ij I not equal to j becomes 0. Dot epsilon kk or ekk, whatever the notation you are following, we can write this. Suppose we have to write sigma xx. How I can write? 2g epsilon ij becomes exx plus lambda constant, that is the Lamb's constant. Like I equal to j, then delta ij equal to 1, then it will be summation with respect to this xx yy ezz. Okay, again for yy I can write it 2g eyy plus lambda exx plus eyy plus ezz. Okay, for similarly we can write it for the zz, 2g ezz lambda ezz exx plus eyy. Okay, for the shear component like xy, then 2g exy. Okay, and this condition becomes 0 because delta is a, when I equal not to j is 0, delta is a is 0. So this condition is sigma yz. Similarly 2g eyz sigma zx 2g ezx. Okay, so this is very much important here. So now for screw dislocation, we know strain value epsilon xx, epsilon yy, epsilon xy all is equal to 0. Only we have xz and epsilon yz, or you can write exx, exj, eyz. We have only this. So now sigma xx will be equal to 0, sigma yy also equal to 0, sigma zz equal to 0. Why I am saying this? Just observe this equation. Like exx is 0, exx eyy ezz is equal to 0. In case of sigma yy, this is 0, all this term is 0, this is 0, this is again 0. Okay, now for sigma xy I can, what I can write it, sigma xy is also 0 because this term is 0. Now the only two components are sigma yz, which is 2g. Now I have to write eyz well. So in the previous lecture what we have seen, yz value is b Berger vector divided by 4 pi, okay, cos theta by r. So put this equation, put this value. Let me use different color. 2g b by 4 pi cos theta by r Okay, for sigma zx or sigma xz 2g, again b by 4 pi sine theta minus sine by r. Okay, so here we have shear stress field also. This is what shear stress field. Okay, now what I want, like in the previous lecture, what I said, the stress field or strain field is symmetrical around radial direction. Okay, so how we can understand this? Before understanding this, let me draw cylindrical coordinate like that. What I am drawing here. I am drawing just cylindrical coordinates. Okay, so how I can denote the axis? This is z axis, this is r axis, and this is theta. Let me use different color. So this is the z plane. This is radial plane, radius plane. This is theta plane. So let me write different component here. Okay, so how I can write, this is sigma zz, this is on z plane in r direction, this is z plane on radius direction, this is on theta plane in z direction, this is on theta plane along r direction, this is sigma theta plane on theta direction, this is on radius plane, it means radial plane along what direction, r direction, this is on radius plane along theta direction, this is radius plane on z direction. Now what I want to do, like let me draw z plane, let me draw z plane. Suppose this is our z plane, and let me draw x-axis and y-axis. This is x-axis, this is y-axis. Now suppose this is your radius which is making theta angle. Okay, this is sigma xz. Suppose this is sigma yz. Z plane in x direction, z plane in y direction. So this is the radius direction, and it has a value of stress component on z plane in r direction, and tangent along theta direction, sigma z on theta direction. So now I want to do component of this xz. I can write it sigma xz here also and sigma yz here also. So this is theta, then again this is theta, this is again theta. I can draw line here also. Okay, so let me take the component along sigma rz and sigma theta z direction of this component, like sigma xz and sigma yz. What I am taking components, taking components of sigma xz and sigma yz along sigma rz and sigma theta z. Okay, so first let me write here. Okay, I am writing with different color so that it would be easily sigma rz along sigma rz. This is sigma xz cos theta. For this one, sigma yz sin theta. For along sigma theta z direction, for theta z direction I am writing this minus sigma xz sin theta plus sigma theta z, not theta z, we are taking component along the sigma theta z. I am taking component of this value, so sigma yz cos theta. Okay, so now let me take first sigma rz. Sigma rz would become sigma xz cos theta plus sigma yz sin theta. Let me put this value sigma r sigma xz and sigma yz. So what was the value of sigma xz here? Sigma xz, if I remember correctly, this is b by 2 pi, and this will be y x square plus y square, or you can write it in terms of polar coordinate as well. Let me write in the polar coordinate, and we have values like sigma xz. For sigma xz we have uh, minus sin theta by r. This is 2g minus sin theta by r cos theta, and p by 4 pi plus 2gb by 4 pi cos theta by r sin theta. Now taking common 2gb by 4 pi r, this is minus sin theta cos theta plus sin theta cos theta. So this would become 0. So on jet plane along the radial direction, the space is 0. Okay, now I am evaluating sigma theta j on jet plane in theta direction. So what I can see here, what we have evaluated, this value. Okay, let me copy this value. Okay, I can paste it here. Okay, let me, for the sake of simplicity I am doing that thing. Let me write now minus sigma xz sin theta plus sigma yz cos theta. Now putting the value of sigma xz value we have already put it here, 2gb by 4 pi minus sin theta by r sin theta plus, let me erase it. Okay, now 2gb by 4 pi cos theta by r cos theta. So 2gb by 4 pi r taking common, this minus minus becomes plus, becomes sin square theta, this is become cos square theta. So this becomes 2gb by 4 pi r, or I can happily write it 2 pi r. Okay, so we have a trace value on jet plane along theta direction, gb by 2 pi r. That means sigma theta j depends on r value. So if I draw sigma theta j, then I will get stress field like this. This is x, this is y. Okay, so we will get the our stress field like this, which is radial symmetric. Okay, now I want to clear one more thing, like when r is r naught, this is the radius of dislocation core. Okay, this is the radius of dislocation core where our assumptions are not valid, means our model is not applicable when r is less than equal to r, when less than r naught. Okay, model is not valid. This is in the previous lecture itself I was mentioning. So here also the stress field depends on the r value. Okay, so here we have understand about the polar about the stress field around the screw dislocation, and what we have seen that the stress field around screw dislocation have only two components, sigma yz and sigma zx, because the we have strain along only the yz and zx. We have strain component only in yz and zx, so we have stress component also, and our shear stress field is radial symmetric. Okay, so we have proved it mathematically why it is radial symmetric. So in the next lecture we will learn about edge dislocation and the stress field around the edge dislocation. And one more thing, what we have calculated stress field like sigma x z, jet plane in x direction, what we have seen, we will we can draw the stress field like this. Suppose this is your x, this is your y, so we can plot yz. This is an interchangeable term, zx and xz. Okay, sigma xz equal to sigma zx because of the symmetry. Okay, so I want to write sigma xz for sigma xz, so it would be like this. The stress field is like this for sigma yz. For sigma yz it would be like this. Okay, and radial direction for sigma theta z, I have shown that it would be like this, and minimum radius are not, which is the dislocation core where our elasticity assumptions are not valid. So this is what we had in this lecture, and in the upcoming lecture we will talk about the dislocation, edge dislocation, and the stress field, strain field around the edge dislocation. Till then, bye bye, and thank you for watching.